In the second lecture, we will cover the following statistical concepts: random variable, probability distribution of a random variable, and important measures of a probability distribution. In this slide, we learn the concept of a random variable. A random variable is a variable whose possible values are numerical outcomes of a random phenomenon. For example, we may toss a coin and get a head or a tail. If we assign head as 1 and tail as 0, then the result of tossing a coin may be represented by a random variable with two values, 0 and 1. If a variable has only one outcome, we may call it a constant variable. The random variable must have more than one outcome, and its value set is the sample space. For example, rolling a dice may give you a random variable with the sample space 1, 2, 3, 4, 5, and 6. Random variable may help us describe a random phenomenon. For example, if a random variable y is the sum of rolling two dice, then t y less than 7 tells us the probability the sum of two dice values is less than 7. Here, the sample space is 2 to 12, and the event is all outcomes less than 7, which is a subset of the sample space. Not only tossing coins or rolling dice, many activities can be represented by random variables. Two keys are helpful to identify the random variable. A random variable has more than one outcome, and the outcomes are numerical. If the outcomes are not numerical, then we have categorical variables, and thus categorical variables are not random variables. There are two basic types of categorical variables: nominal variables and ordinal variables. A nominal variable doesn't have a natural order or ranking. For example, the gender is a nominal variable. The outcomes of an ordinal variable have an intrinsic order. For example, the education level is an ordinal variable. The categorical variables may be converted to the random variables. For example, we toss a coin and get a head or tail. What is the average value of the head and tail? It doesn't exist. We need to convert the categorical variable first. For example, assign head as 1 and tail as 0. This procedure is called coding. Through the use of coding systems, almost all statistical softwares accept categorical variables. There are two basic types of random variables: discrete random variables and continuous random variables. The sample space of the discrete random variables has only discrete numerical values, and the sample space of the continuous random variables is infinite and uncountable. For example, tossing a coin may give us a discrete random variable. The sample space has two values, 0 and 1. The heights of all adults in the US may be described as a continuous random variable, since the sample space is a range instead of discrete numeric values. Now we know Random variable has more than one outcome. The next question is the probability of each outcome. This is known as the probability distribution of a random variable. The probability distribution is a mathematical function that provides the probabilities of all possible outcomes of the random variable. For example, when we toss a coin, there is 50% chance that it lands on head and also 50% chance it lands on tail. Thus, the distribution tells us the probability of each outcome. Another example, if we roll a dice, the probability of each outcome is 1 over 6. This table shows the distribution of the random variable. We call the distribution of a discrete random variable probability mass function, PMF, and the distribution of a continuous random variable probability density function, PDF. The cumulative distribution function, CDF, is capital Fy. It sums the probability for outcomes less than or equal to value y. We may also use histograms to graphically display the distribution of a random variable, especially for continuous random variables. The right graph is a standard normal distribution generated using R software. The PDF of the standard normal distribution is this. In this slide, we discuss two important measures to describe the center of the distribution, mean and the median. In a group of numbers, the mean is the average value, and the median is the middle value. As discussed earlier, we may need to pay attention to the population mean and the sample mean. The population mean is the mean of the population, which is a parameter, and the sample mean is the mean of the sample, a statistic. Below is a simple example to explore the difference between the mean and the median. We have a set of outcomes, 1, 2, 3, 4, and 200 forms the sample space. Then the mean is the average of the 5 numbers, which is 42, while the median is the middle number, which is 3. In this case, the mean and the median is quite different. The example tells us that the mean is sensitive to extreme values, but the median is not. In the example, if we change 200 to 400, then the mean increases from 42 to 82, while the median is still 3. The difference between the mean and the median may give us some information about the distribution. The mean of the distribution is called the expected value or expectation, written as EY. The expected value has these two basic properties, since the expected value is the arithmetic mean. Here, C is a constant. Variance is variability of the distribution of the random variable. It measures how far the distribution spreads out from its mean. We may write variance as sigma square or this. The variance of a random variable is the expected value of the squared difference between the random variable and its mean, and may be calculated by this formula, provided that the expectation exists. Not all distributions have expected values. For example, culture distribution does not have an expected value, thus it also does not have a variance. Here, sigma is the standard deviation, which is the square root of the variance. If we add a constant to random variable y, the variance doesn't change since the variability doesn't change with the shift. If we multiply a constant to y, the new variance is squared c multiply its variance. We derive the two properties here and should be easy to understand with the help from the properties of the expected values. In this slide, we continue to talk about other important distribution measures. First, mode. The mode of a distribution is the points at which the values that occur most often. We previously showed the standard normal distribution. It has a mode at 0, as we can see from its density function. If a distribution only has one peak, then it is unimodal. And if a distribution has more than one peak, then it is multimodal. Next, quantile, percentile, and quartile. The p-quantile of the distribution is the smallest y such that fy equal to p. In R software, the function quantile gives the p-quantile of the distribution of random variable y. Percentile is 100 times of the quantile. For example, 0.5 quantile and 5th percentile is the median, which divides the distribution into half. Quartile divides the distribution into quarters. So first quartile is 0.25 quantile or 25th percentile. Finally, we briefly discuss skewness and kurtosis. Skewness is a measure of symmetry. For a unimodal distribution, negative skew indicates the distribution is skewed left, and positive for the distribution skewed right. A symmetric distribution such as the normal distribution always has zero skewness, but the reverse may not always be true. Zero skewness doesn't mean the distribution is symmetric. Kurtosis is a measure of tails, and the normal distribution has a kurtosis of 3. If the kurtosis of the distribution is larger than 3, then it is heavy-tailed. If it is smaller than 3, then it is light-tailed. In summary, we studied the random variable, the probability distribution, and some important measures of the probability distribution in this lecture. A random variable is a variable whose possible values are numerical outcomes of a random phenomenon. It must have more than one outcome, and all outcomes must be numerical. Thus, categorical variables are not random variables. There are two possible types of a random variable. discrete random variable and the continuous random variable. The possible outcomes of a discrete random variable are countable, but the possible outcomes of a continuous random variable are not. The probability distribution of a random variable is a mathematical function that provides the probabilities of all possible outcomes of the random variable. The distribution of the discrete random variable is the probability mass function Py, and the distribution of the continuous random variable is the probability density function Fy. The cumulative distribution function, capital Fy, is the probability that the random variable y will take value less than or equal to value y. Last, we introduce some important distribution measures. Mean is sensitive to extreme values, while median is not. Expectation, or the expected value of the distribution Ey, is the mean of the distribution of the random variable. Variance, sigma square, is the variability of the distribution of the random variable, and the sigma is the standard deviation. The mode of a distribution is the points at which the probability distribution function is maximized. Skewness is a measure of symmetry, and kurtosis is a measure of tails.